Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the math portion of the GRE. We have been solving math problems out of this book here, the official guide to the GRE, the revised general test. The problem that I'm about to solve is the one that you're going to find on page number 126. Today is our day number 21. The exact same problem that we are about to solve right now, from page 126 out of this book here, is the problem that you will find that appeared in the old exam, in the old version of the GRE, which is this book right here, the 10th edition. If you can somehow get hold of this book here, it contains 7 exams. Each exam has 30 quantitative comparison questions, and those quantitative comparison questions still exist in the new exam. So there are 7 exams in this book. Each of them has 30 questions. There are 210 quantitative comparison questions here, an excellent source for you to practice on. And I have posted a video of all 210 quantitative comparison questions if you're interested in watching those videos. Just type in, just look for the GRE quantitative comparison playlist on my channel. But if you want to compare the problem that we are about to do with the old version of the problem, just type in this tag here, day 22, page 136. Day 22, page 136, quantitative comparison, and you will see it. Anyway, let's get going. I hope the book is in front of you, because I don't have a luxury of reading the entire problem to you. We have 2 machines. We are told that one machine takes 10 minutes to make K parts. Machine B takes 15 minutes to make K parts. The question simply is, how long will it take them if they are working together at their constant pace to make K parts together? There are 2 ways you can solve this problem. One is what I would call the classical way, the orthodox way, the geeky way, the nerdy way, the traditional way, the academic way, the mathematical way, the algebraic way. Another one is what I call the quick and dirty way. In the quick and dirty way, what you do is you make up a value for this variable. You plug in a number. You plug in, this is called the plugging in technique. Plug in numbers. Now, with the plugging in techniques, the trick is that you have to plug in some numbers that works nicely, that makes your life easier, that makes the math simpler. So let's plug in something for K. Let's make up some value for K. Let's pretend K is 4. So as you can see, now it says A makes 4 parts in 10 minutes. If it makes 4 parts in 10 minutes, how many parts will it make in 1 minute? As you can see, it's not a nice number to plug in. It's not a nice number, because how many will it make in 1 minute will be 4 over 10. It will be ridiculous. Now if you had plugged in 40 here, if we had plugged in 40 for K, it would have been easier. If it makes 40 parts in 10 minutes, then in 1 minute it must make 4 parts. Very simple. But the problem is, once we get to here, we have the same K, so it's 40 here. So now we have 40 parts in 15 minutes. As you can see, you cannot divide 40 easily into 15. I can divide 40 easily into 10, but not into 15. So that's where the practice comes into it, where be able to figure out what's a nice number to plug in within a matter of seconds. Well, I just said seconds, but what I meant to say is within a matter of a fraction of a second. A good number to plug in, something that goes nicely into 15 and 10, will not be 30, or would not be 40, but rather 30. So let's pretend K is 30. This is called plugging in, 30. Whatever you plug in for K here has to be same here, obviously, because it's the same variable. So now the problem reads like this. So what we have done now is that we have taken a fairly complicated algebraic problem and converted it into a very simple arithmetic problem. What the problem says now is A makes 30 parts in 10 minutes. If it makes 30 parts in 10 minutes, this implies that it must make 3 parts in 1 minute. Similarly, B, we have 30 parts in 15 minutes. That implies that it must make 2 parts in 1 minute. Well, if it makes, I made such a long line, I just realized that we are done. That's it, that's the end of it. So, if A makes 3 parts in 1 minute and B makes 2 parts in 1 minute, together, working together, they must make 3 parts in 1 minute, A makes 2 parts in 1 minute, B makes Together they must make 5 parts per minute. Well, if it's 5 parts per minute, the question simply is, how long will it take for them working together to make k parts? K in our case is 30. We plugged in 30 here. So now the question is, how long will it take them to make 30 parts if they are making 5 parts in a minute? Well, if they're making 5 parts in a minute, 30 is just 6 times the amount. So it must be, this is 1 minute, it must be 6 times the amount. Voila, that's it. We are done. 5 parts in 1 minute, therefore 30, which is 6 times the amount, must take 6 minutes. That's it, we are done. The answer is 6 minutes. Now if you like, just to satisfy your curiosity, we can redo the problem in the classical way, in the algebraic way, if you're curious, if you're hell-bent. I need the room, so I'm going to have to erase everything, but as far as the work is concerned, we are done. The answer is 6 minutes. Again, one more time, I'm going to go over this very quickly. We plugged in 30 for k. Why 30 for k? Because 30 goes evenly into 10 and 15. You can plug in 30, you can plug in 60, but whatever you do, do not plug in any number that appears in the problem. Do not plug in 15. Don't do that. It causes problem, because then 15 parts in 15 minutes, you're looking at 1 part per minute. Don't deal with 1, because 1 does not evolve with the problem. You want numbers that evolve with the problem. 1 times 1 is 1, 1 squared is 1. It doesn't evolve. 1 is a number that can potentially cause you headache. So avoid it. Do not plug in any number that appears in the problem. Do not plug in any numbers for the variables that appear in the answer choices, if you had answer choices. Here, of course, we have no answer choices. So we plug in 30. 30 goes evenly into 10 and 15. 30 parts in 10 minutes, which means 3 parts in 1 minute. 30 parts in 15 minutes, which means 2 parts in 1 minute. 3 parts here, 2 parts there, 5 parts, 1 minute. 30 parts, which is 6 times 5, should take 6 minutes. That's it. Let's do the same problem in algebraic way. And then I want you to go, as I said already before, then I want you to type in, after you finish watching this thing, just type in this tag, just put in day 22, page 136, quantitative comparison, and watch that video, my old video that I put in about 3 years ago, and compare the two problems. See what you find. So now let's do the same problem in a classical way. We are told that in 15 minutes, A makes k parts in 10 minutes. Well, if A makes k parts in 10 minutes, A must make 1.5 times k in 15 minutes. This is where the algebraic portion comes in. This is where the geek genes kick in. Why 1.5 times k? Because k is 15. K in 10 minutes. 15 is 10 plus 5. In 10 minutes you're making k parts. So in another 5 minutes you're going to make half of k, whatever the k happens to be. And therefore in 15 minutes you're going to make 1.5 k. So that's how many you're making, 1.5 k in 15 minutes. Let's look at machine B. That's it, we are done. This was just for explanation. B makes k parts in 15 minutes. So A makes 1.5 k in 15 minutes. B makes k parts in 15 minutes. Together they make 1k and 1.5k, 2.5k in 15 minutes. Okay, now watch what happens. Instead of 2.5k in 15 minutes, I'm going to put in some simpler number first to make you understand the concept. If we had 3k in 15 minutes, how long will it take for 1k? 1k will be in 15 over 3 minutes. Makes sense. If you're making 3 of something in 15 minutes, 1 of something should take 5 minutes. Instead of 3, if we had, I'm going to change the color so you can see it now for emphasis. Instead of 3, if we had 5k in 15 minutes, then 1k must be 15 over 5. We do not have 3, we do not have 5, we have 2.5. So that's what it is, 15 divided by 2.5. That's how many minutes it will take to make 1K. All we have to do is figure out this quantity, 15 divided by 2.5. Let's do it here. 15 divided by 2.5, well 2.5 is same as 5 halves. 5 halves are 2.5 because one is 2 halves, another one is another 2 halves, that's 4 halves, and then another half, 5 halves. 5 halves are 2.5. So 15 divided by 2.5 is same as 5 over 2, which is same as 15 times 2 over 5. And of course this 15 has 1 underneath it. But of course if I needed to explain all of this thing in this excruciating details, then you're not cut out for this thing. I don't mean to put it in such a harsh, such a blunt manner. You're not cut out for this thing if it requires this much explanation for you to understand it. Just stick with the plugging in technique, you'll be fine. But anyway, we're almost done. This 15 goes into 5 3 times, and there you go, 3 times 2. 3 times 2 is 6, which is what we found for the answer. That's it, we are done. That was the answer. So that's a classical way, more traditional way, more academic way if you like. The other method that we did, the plugging in method, is the more straightforward method. Just plug in a number, plug in some nice number that makes your math simpler, and you'll be fine. Alright? I'll see you tomorrow on day number 22. Okay? Bye now.